Hello viewers, in today's class we are going to discuss an interesting and conceptual problem from limits and continuity of functions. Right, so here we are given a function which is defined in this way, that is, this function is expressed as a piecewise function, and this function is given to be continuous at x is equal to 2, and we have to find the value of lambda, where lambda belongs to the set of real numbers. Right, so now let us first quickly revise the definition of a continuous function. A function is said to be continuous if the limit, that is limit x tends to a, f of x is equal to the value of the function at that particular point. Right, so this is the definition of a continuous function. A function is said to be continuous at some point x is equal to a if this limit exists and the limit is equal to the value of the function at that particular point. Right, and in order to find out this limit, we have to calculate the right hand limit and the left hand limit. Right, and we'll see that both the right hand limit and the left hand limit exist and finite, and these two limits are equal. So when the right hand limit exists and finite, left hand limit exists and finite, both are equal, we say that this limit exists. Right, and if this limit is equal to the value of the function at that point, then we say that the function is continuous at that point. So here x is equal to 2, that is, we are given that the point at which we have to test the continuity is a is equal to 2. So now let us first find the right hand limit. Right, so right hand limit is given by limit x tends to 2 plus, and here we have f of x. Right, so here we have the point x is equal to 2, and when we calculate the right hand limit, it means we are approaching from the right of x is equal to 2, and all the values which lies towards the right of x is equal to 2 are greater than 2. Right, so here we'll take f of x as this function. So now we can write limit x tends to 2 plus, and for fx we can write x minus greatest integer x over x minus 2 plus 4. Now here what we will do, we'll put x is equal to 2 plus h, and here as we usually adopt this method to calculate the limits, so we'll put x is equal to 2 plus h, where h is greater than 0 and h is a very small quantity. Right, so when x tends to 2, h tends to 0. Right, so now the right hand limit is given by limit. Now we'll replace x tends to 2 plus by limit h tends to 0, and for x we can write 2 plus h. So here we have 2 plus h minus greatest integer of 2 plus h divided by 2 plus h minus 2 plus 4. Right, now we have to assign the value to this term, that is the greatest integer of 2 plus h. Now as we have just said that h is a positive quantity and h is a very small quantity, so therefore when we add h to 2, then this quantity 2 plus h is slightly greater than 2, but it is less than 3. And from the definition of greatest integer function, the value of greatest integer of 2 plus h when 2 plus h lies between 2 and 3 is given by 2. Right, so now we can write limit h tends to 0. Here we have 2 plus h minus, for this we have 2, and now we have 2 plus h minus 2 plus 4, and this is limit h tends to 0, and 2 get cancelled. We have h here, 2 and 2 get cancelled, and we have h plus 4, and h get cancelled, so this is 1, and 1 plus 4 is 5, right? So the right hand limit of this function at x is equal to 2 is 5. Now let us calculate the left hand limit. So the left hand limit is given by limit x tends to 2 minus, right? And here we have f of x. Now when we calculate the left hand limit, it means we are approaching from the left of x is equal to 2, and all those values which lies towards the left of x is equal to 2 are less than 2, right? So in this case, now we'll take f of x as this function. So now we can write limit, this is x tends to 2 minus, and we have here x plus mod of x plus 1, and in the denominator we have x minus greatest integer of x, right? So now here again we'll make the substitution, x is equal to 2 minus h, because in this case all the values are less than 2, so we'll take x is equal to 2 minus h, and again h is greater than 0, and h is very small quantity. So when x tends to 2, h tends to 0. So now the left hand limit is written as limit. Now this limit is replaced by limit h tends to 0, and for x we can write 2 minus h plus mod of 2 minus h plus 1, and here we have 2 minus h minus greatest integer of 2 minus h. Now again let us assign value to greatest integer of 2 minus h. Now as we have just said that h is greater than 0, but it is a very small quantity, so 2 minus h is slightly less than, here we can write it as 2 minus h is greater than 1, but it is less than 2, right? So 2 minus h lies between 1 and 2, because h has some value, however it is very small, but when we subtract h from 2, we get a number which is greater than 1 but slightly less than 2. So by definition of greatest integer function, the value of greatest integer of 2 minus h is equal to 1, right? So now we have here a limit h tends to 0, this is 2 minus h, plus here we have 2 plus 1 3, so we have 3 minus h, mod of 3 minus h divided by 2 minus h minus 1, right? So this is limit h tends to 0, 2 minus h, and here 3 minus h is obviously greater than 0, so we can write it as plus 3 minus h, and here 2 minus 1 is 1, 1 minus h, and this is limit h tends to 0, this is 3 plus 2 5 minus 2h, and this is 1 minus h, and when h tends to 0 we have 5 minus 2 times 0, and here we have 1 minus 0, so this is 5 minus 0 over 1 minus 0, that is 5, right? So the left hand limit is also equal to 5. So now viewers, we have just seen that the right hand limit is equal to the left hand limit, and both these limits are equal to 5, right? So therefore we can say that limit x tends to 2 and f of x is equal to 5. It means the limit of this function when x approaches towards 2 either from left or from right, the limit is given as 5, and now we can write f of a. and a is 2, that is the value of the function at this point. So f of 2 is given as lambda square minus 1, right, where lambda is some real number, and since this function is given to be continuous, therefore by the definition of continuous function, the limit x tends to 2, f of x must be equal to f of 2, right? So this is 5 and f of 2 is lambda square minus 1. So lambda square is 5 plus 1 and lambda square is 6. So lambda is square root of 6, right? So the value of lambda is given by square root of 6 when f of x is defined in this manner and it is given to be continuous at x is equal to 2, right? So this is how we solve this important and conceptual problem.